Hello and welcome to R&D Mathematics. Today I will start by telling you a story. Once upon a time, there was a guy and he was a rich, cunning person who takes money from poor people and becoming rich. He's the kind of person who destroys this world. This rich guy was there. And everybody was so afraid of him and doesn't like him, but couldn't do anything about him because he's rich. And in the same country and near a forest, there was a monk, very wise guy. Now the villagers came to the monk because the monk is very wise. This is wise monk. And this guy is rich, cunning, don't think about others. So the villagers came to monk because he is a wise guy and asked the monk, can you help us? And the monk listened to their story and said, okay, I'll do something. And then monk came to rich guy and the following conversation happened. So the monk said, I have a proposal for you. I have a suggestion. Rich guy asked, what is it? And monk said, I'll give you $100,000 today and another $100,000 tomorrow. And every day for the rest of this month, $100,000 every day. I will bring you $100,000 every day for 1 month. Now this conversation happened first day of the month. So let's say this first day of the month. And the rich guy was kind of shocked. I mean, there must be a catch, right? So in return, then the monk said, you just have to give me $1 today, $2 tomorrow, $4 day after tomorrow, and so on. So you have to give me twice as previous day. This is what you have to do. Now, and the rich guy thought, okay, rich guy in his mind, he thought, what a fool. What a fool. He didn't say that. He thought, okay. He thought, what a fool. And he said, okay, let's do that. Now, this was the deal. Now, let's see how it went. So, let's say amount of money received at the end of each day. So, amount of money received. Let's make this column the number of days column the first day. So, let's say rich guy and wise guy. First day, rich guy received, so let's say it's in dollars. First day, rich guy received 100,000. And second day, again 100,000. So this guy is receiving 100,000 every day. So this is second day, third day, fourth day, and so on until last day. Let's say we only have 30 days. And in total, he is receiving 30 times 100,000. So 30 of 100,000 this much. So that is the total. So when you add all these numbers, this is what he is getting. So for example, by fourth day, rich guy is pretty happy, right? Fourth day, rich guy is happy. He is pretty happy. But let's say what's happened to wise guy. Now wise guy is only receiving, the very first day he's only receiving $1 and $2 and then $4 and then $8. And the fifth day, let's say fifth day, he's receiving $16, and then 32, and so on. So we see a pattern. So for example, 8 is actually previous time 4 times twice, but 4 is previous time 2 times 2. 2 is previous time 1 times 2. So we see a pattern. This number is 2 to the 1, this number is 2 to the 2, this is 2 to the 3. Actually, the first number is 2 to the 0. Remember, 0th power is any number is 1 except 0. So this is 2 to the 4, this is 2 to the 5, and there is a pattern. So the first day, 0th power, second day, first power, so 1 less. Third day, second power, fourth day, third power, fifth day, fourth power, and sixth day, fifth power, and so on. So the last day, well, before going to last day, let's go around, let's say 25th day. So somewhere here, 2 to the 25th. Now, what is that number? Use your calculators and check, guys, what is 2 to the 25th? Let me see it. 2 to the 25th equals, this is what my calculator gives me, 3355443. See, this is pretty large. Now, what's happening here is, first few days, it seems like still at this point rich guy is happy. Now let's say, how about 2 to the 10? Somewhere here when it is 2 to the 10, that's 1024. So the 11th day, still rich guy is happy. But very soon, somewhere around, I don't know, maybe 20th, 21st day, 2 to the 20. Let's check 2 to the 20. So let's take 2 to the 20 is, what's that number? 1048,576. See, at this point, this number is much larger than 100,000. If you calculate, see, 1, 2, 3, 4, 5, 6 digit, and here 1, 2, 3, 4, 5, 6, 7 digit, almost 10 times larger. So at around these days, rich guy realized, okay, he's in a big trouble. So wise man actually gave rich guy a very good lesson. Not just that, let's look at the last number, 2 to the 30th. That's going to be a pretty huge number. So 2 raised to, let me quickly find it using the calculator. That's 1073741824. Most probably rich guy ran out of money. He did not continue until this point because he did not have that much of money. So you see, in this example, in this little proposal, this is not the amount of money this wise guy is receiving. He is receiving this plus, see, all the day before that, 2 to the 29. That's a huge number. So you have to add all these numbers. So this is a pretty big amount. And only rich guy is receiving this much, 30 of 100,000. Now, the story has a nice mathematical part. 2 to the x is a exponential function. The word exponent means it is growing very rapidly. As you see in this example, exponential function. Now, today we are going to actually talk about, in general, exponential functions. So, I recommend you to watch my second video in this series, College Algebra 2, Properties of Exponential Function. If you cannot remember those properties, because we are going to use those properties again and again. Now, an exponential function is defined by fx equal b to the x. As the name suggests, our variable now is in the exponent, where b has to be positive and b is not 1. Well, of course, the reason not 1, because 1 to the x is always 1 for any x. It's not, well, it's not that special, so we avoid that. Now let's see some examples. F of x equal 3 to the x, that's an exponential function. G of x equal 1/4 to the x, that's an exponential function. H of x equal 10 to the x minus 2. Still, yes, exponential function because our variable is in exponent. Now using them, let's say f of 2. Let's evaluate them. F of 2, you just have to do 3 to the 2, which is 9. And let's say g to the negative 1, you just have to do 1/4 raised to negative 1. Now the properties of exponent numbers is really helpful here. So 1 raised to negative 1 is just 1, and 4 raised to negative 1, it comes 4 raised to positive 1 when you turn upside down. So the answer is 4. And let's say h of 3. So 10 to the 3 minus 2, which is 10, to the 1, which is 10. And f of 0, 3 to the 0, which is 1. See, these are exponential functions. Now let's have a look at the graphs. In order to draw the graph, we'll start with an example, 2 to the x. So f of x equal 2 to the x. Now, as I always tell you, the easiest way is to start with, a table. Once you remember it, you don't have to use it anymore. But let's see, let's take some values. Negative 1, 0, 1, 2, negative 2. So 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the 1, and 2 to the 2. 2 to the 2 is 4, this is 2, this is 1. 2 to the negative 1 is 1 over 2 to the 1, which is 1/2. And this is 1 over 2 to the 2, which is 1/4. So if you try to draw this, so negative 2, negative 1, 0, 1, 2, I'm only labeling x values here. So at negative 2, it's 1/4. So let's say 1 is here, 2 is here, 3 is here, 4 is here. So 1, 2, 3, 4. 1/4 somewhere here. 1/2 somewhere here. 2 to the 0 is 1, so here. 2 to the 1 is 2, so 1 comma 2 here. 2 to the 2 is 4, so here. Now you see the shape. Exponential function always have this kind of shape. And this x-axis is a horizontal asymptote for this graph. Because your graph will never touch it, it gets closer and closer and closer. The reason is, okay, let's go this side. 2 to the negative 1000. This means 1 over 2 to the 1000. So 1 over very large number, very close to 0. 0.000000000 something. I don't know. You can use a calculator. So it's a very small number, but it will never be 0. So this is the shape of an exponential function. Now let's have a look at, in order to complete this theory part, how about if you had 2 to the negative x? Is this an exponential? Yes, of course. The 2 to the negative x is same as 1 over 2 to the x, or that is same as 1/2 raised to the x. Again, if you don't get those things, those are properties of exponent. Please watch video number 2. Now let's draw this, and you will see an amazing thing with this. X and 2 to the negative x, which is same as 1/2 2 to the x, also 1 over 2 to the x. They all same. So negative 2, negative 1, 0, 1, 2. Now 2 to the x itself is negative, so 2 to the negative negative 2, which is 2 to the 2. Similarly 2 to the 1, 2 to the 0, 2 to the negative 1 and 2 to the negative 2. Now let me go to the previous values. See, please look at this column. If you observe, that column is actually reversed here. So here 4, 2, 1, 1/2 and 1/4. So when you draw the graph, at negative 2, y value is 4. So 1, 2, 1, 2, 3, 4, somewhere here. At negative 1, y value is 2. So 1, 2, right here. At 0, 0. And at 1, 1/2. So somewhere here. 1/4. See, it is reversed the shape. So in general, now let me write down in general. So in general, exponential functions will always have one of these two shapes. So if b is greater than 1, so our base, so the graph of b to the x, and if b is less than 1, the graph of b to the x. So if b is greater than 1, like 2 to the x, graph will always look like this. And let's write down some properties. So this is increasing, strictly increasing. Strictly increasing means always it's increasing. There are no places where it's constant. Increasing. And this is x, this is y. And in this case, the other way around, like this. So it's strictly decreasing, strictly decreasing. And this is y, this is x. And horizontal asymptotes in both cases, horizontal asymptotes equal x-axis. X-axis. See, x-axis, see this guy, it works as an asymptote. Your graph keeps limit into it. And in both cases, domain is negative infinity to infinity. In both cases, range, so both cases, range, sorry, domain is 0 to infinity. Oh, no, domain is negative infinity to infinity. Range is 0 to infinity, because now again, guys, basics. If you project your graph to x-axis, you get everything. But if you project it to y-axis, you only get everything above y-axis, not including 0. I told you, because see, this is horizontal asymptote x-axis. When you project it, your graph will never be 0, but it's get closer to 0. Closer and closer to 0. And again, for both x-intercept, right, x-intercept, none, because it does not cross. And y-intercept, again, for both, even though they look completely opposite, for both y-intercept this point, 0, 1. So this is again true for both. See, all these properties are same for both, but they have two different shapes. One is strictly increasing and one is strictly decreasing. So that's the basic shape. Now, for example, if you had 5 to the x, well, it will look like this. This point is still 0, 1, because 5 to the 0, that point is 5 to the 0. 5 to the 0 is 1. That's how you get y value. The only, okay, you may be thinking, what's the difference between 2 to the x and 5 to the x? Okay, let me draw those things, both of them. So 2 to the x and 5 to the x. Roughly speaking, 5 to the, if this is 2 to the x, 5 to the x will be increasing much rapidly. So 5 to the x, they cross at the same point. So this is 5 to the x. So like that. So that's the only difference. And I think with that being said, and similarly, you can figure out one fifth to the x and the relation between 1/2 to the x. So now they go the other way around, like those. Well, like this and like this. So this point still 0, comma 1. Now that's pretty much about, okay, now one more thing. So how about if you had to, let's say you had to draw 5 to the x minus 1, now what? And 5 to the x plus 1, and 5 to the x, then minus 1, and 5 to the x, then plus 1. See, I recommend you to watch video number 26 for horizontal and vertical shifts. Now let me quickly address them. So this guy over here, what will happen is, if the original function 5 to the x look like this, it will go 1 unit up, 1 up. And this one, it will take 1 down. So like this, because of this minus 1. And this one and this one, they are horizontal transformation. So this will take to the right, this will take to the left. So this guy will take it to right 1 unit. So something like this. And this one will take it to the left 1 unit. So something like this, right? So I believe, and yeah, that's all about. But let's say you have in this guy, let's say you have to find x-intercept none. So how about y-intercept? Y-intercept. If you want to find y-intercept, the way you have to do is put x equals 0, right? So when you put x equals 0, 5 to the 0 minus 1, so 5 to the negative 1, negative 1 over fifth. So y-intercept is 0, comma 1 over fifth. Now, does that make sense? Yes, of course. If you look at the graph, the original one, the base function 5 to the x look like this, and it will shift 1 unit to the right. When I say 1 unit to the right, so whatever happened at this x value at 0, now it's happening at x equal 1 value right here. Now, when that happens, see this, the place where you hit your y-axis has actually gone down here, because you drag it to the right, and it seems like it's much less than 1, which makes sense, 1/5, right? That's how you find x-intercept. And other than that, domains, range, all those things with this horizontal shift, it will not change. You know what, let me do this. So let's say f of x equals 5 to the x minus 1, as we, so the graph will move 1 unit to the right because it's a horizontal transformation. So this will happen somewhere here, 1 unit to the right. So the required graph will look like this. And let's investigate this. And we already saw y-intercept is 0, comma 1/5 right here. And how about the domain? Domain of f, well, that's still the same, negative infinity to infinity. Range of f, 0 to infinity, is still the same, right? Now let's see, what if you had this function f of x equals 5x then minus 1. Now what will happen is the base function, it will look like this always, 5 to the x, this base is 0, comma 1, exactly like here, 0, comma 1. Now this will go 1 unit down, so this will be here now. So now the graph will look like this, right? So 5 to the x minus 1. So y-intercept, well, it's obvious 0, comma 0, but let's put x equals 0 in our equation. So f of 0, 5 to the 0 minus 1, 1 minus 1, which is 0, which makes sense. So 0, comma 0 is our y-intercept. Now let's see domain and range. What will happen to the domain? Domain still the same, negative infinity to infinity. How about the range? Range, see, now with this green color dotted graph, this line is the horizontal asymptote. Everything on your graph light above it. But when you drag it 1 unit down, the new horizontal asymptote is y equals -1. This line, this is the new horizontal asymptote. So horizontal asymptote. Because of that, the range, everything above -1s, but without -1. So -1 to infinity. Okay, guys, so that's everything you need to know about exponential functions. Other than that, there is one special thing. See this base, as we were talking about b to the x, this is the form, and b have to be greater than 1, b cannot be 0. B has to be greater than 0, b cannot be 1, and b can be any value. So starting from 0, without 0, and without 1, it can be any value. If you have larger values to this side, you always get this shape, and for these things you get this shape. That's what we learned in the first at the beginning of this video. And one more thing, there is a special base which is known as the natural base e to the x. Probably you have heard about that, but we'll talk about this in detail when we are dealing with logarithmic functions. Okay, that's it for today's video. Thank you.